Hello everyone, and welcome back to the Astroneer Design Mechanics playlist. Now, this time we're going to be talking about movement. There are a lot of complexities that come into movement. For example, we have just a ball lit up right here that we're going to be using as our test case. So we're going to be talking about what causes it to move to each of the different positions, but we're not going to be talking about object collision or deletion or anything like that yet. That's a little bit more complicated. We're just going to be focusing on how we actually get a floodlight here to turn off and move to the next location. And the way that we do it is basically using this little guy right here. It's not as complex as some of the other things that I've discussed, so hopefully it will be a little bit easier to understand. There's just a mess of cable pins and stuff that could be a little bit tricky to figure out, so hopefully talking through those is not terribly complex. Now, I like using generators for these because you can turn them on and off. So when you turn it on, it represents a ball being in that position, and when you turn it off, it represents a ball leaving that position. And the way that we do that is we just have a power sensor on the platform itself in power gained or power lost mode. So when we gain power lost, we turn the floodlight on. When we lose power, we turn it off, and so forth. It's relatively simple with that. But from here, we now have 4 different directions. We can move to the upper left, lower right, upper right, and lower right. And the way that that's handled is we have a switch blocking power coming from each of them. Now, as I said, I like using the generators. In the past, we needed to use them so that we could figure out a power threshold, but now we don't need to worry about that. We only need to worry about a singular switch. And if you guys remember, these switches act like AND gates when in series, but when they're just on their own, they act like a singular condition. So when this condition is met, we're going to move the ball based on what this power sensor tells us to. When this condition is met, we're going to move it based on what this power sensor tells us to. So what exactly are these conditions? These conditions are based on where we came from previously. So this is a cascading style. I previously messed around with trying to use a direction generator as well as for like up and then a direction generator for side to side. That was not quick enough because when those changed by hitting like a wall or a brick or a paddle, they didn't change quick enough to affect all of the generators. So because of that, we use this cascading method. Now, what does that mean? What that means is this ball's direction depends on its previous state. So when we start the game, we need to specify an initial direction. And from there, every other direction is determined. So this ball, we don't have a direction associated with it, so it's not moving anywhere. So to start stuff, we would have to cause one of the switches to toggle, and then it will move accordingly. So say we moved it to the upper right. We moved it to this direction. This will turn off, this will turn on. But this will now have a upper right direction associated with it. So the ball will continue to the upper right until it hits something. When it hits something and causes it to switch, right here, this will cause it to move to the lower right, which again, will have a lower right direction associated with it that will cascade until it hits something and can no longer go anywhere. So that's the premise that we opt to do. So that means that these switches that determine the direction all come from the previous direction. So for example, say we wanted to move to the upper right, this is triggered by that lower left section over here because this caused a power sensor to trigger that would send the ball to the upper right. So we continue with our upper right movement and move one generator up. This one, very similar, except to the upper left this time. We come from a position that sends us to the upper left, we open this switch, let power through, and we move to the upper left direction. And then the lower left comes from the one over here, so it sends us in the lower left direction, and then this one on the lower right comes from up there and sends us in the lower right direction. So that's the general premise of how we handle the directions. And the way that we actually do it is by sending signals with the power sensor at the end of it. Now these guys are only in power gained, and the reason is we don't want to do anything unless we have power coming to them. Because right now the ball's not moving, but if we have a direction associated with this and we open this switch, power will flow through, and we only want to do something once. We don't want to do something twice, so that's why we don't change anything on power lost. So what exactly do we do, as I said? This guy is going to send to the next generator because we're going to move the ball position to the next one, as well as opens the switch for the upper left direction. Because we are going in the upper left direction, we want to continue that, as I said, until we actually hit something that causes us to change it. Now, what it also does over here is it also closes the switch that caused power to come this way. And the reason is because if we were moving in the upper left direction, we don't want to leave this switch open because when we come back to this generator for whatever reason, if this switch is still open, we will move in the upper left direction, even if we were trying to go a different way. So we need to make sure we close this switch, which is exactly what this cable pin does. We also turn off our generator. Because we had the ball in this position, we no longer want the ball in this position, so we're going to turn this off and move and turn on the next one. So we essentially are going to enact this behavior. The ball is right here. We're going to theoretically open the switch, which will turn this generator off, re-close this switch, turn this generator on, and open up this switch, which will allow things to cascade. And as you can see, we effectively moved the ball one position up and to the left. Oops. And that's exactly the premise that we have here. So this cascades for every single one of these generators that you see. We need to have one of these setups for every single one of our ball positions. So that's why there's quite a lot of repetitive units, but they all do the exact same thing. Each of these guys have 5 segments, one to this little pin right here, close the switch, turn off the generator, open the next switch, and turn on the next generator. That's what every single one of these guys do. The only things that differ, however, is when we get to the edge cases. The edge cases, like hitting a wall or hitting a brick or hitting a paddle, are slightly different. We're not going to cover paddles right now just because there's a lot more of a mess for various reasons. But essentially what happens is, similar to the previous generator we looked at, if we're moving in the upper left direction, we're going to close off our switch and we're going to turn off our generator. And we're going to turn on the next generator. But because we're on the wall, we don't have an upper left position to move to. So what ends up happening? We bounce. When we're moving up to the wall, we move to the upper left, but now we move to the upper right. So essentially what this pin is going to do is it's now going to move in the upper right direction because we are reflecting off the wall with a perfect angle of reflection meeting the angle of incoming ball movement. And also because we're doing squares, it's really just 90 degrees either way. So that's a little bit of a math thing that if you want to look at, you certainly can, but it's just a simplified version. Again, this will cause this to turn on, power flow through here, hit the power switch, and then now it's moving in the upper right. And that's really how we handled the ball movement. It's not too complex. We, at least, again, I think I say that every single time, and walking through it, I hope it does make sense, but I know it's probably a little bit tricky. So yeah, that's kind of how it does. We basically move it based on the current position and where it goes. Now, the one thing that I do want to mention is when we are starting this game, which we start the game by driving through either one of these gates over here, which essentially triggers this little fancy button that you see back behind here, we have to specify an initial direction in the first place. So that's why what you see here is these cable pins, they have a double switch. So we have one switch to handle the direction movement, but we also have another switch to determine if we can actually move in that direction, or if we can actually start that way. So that's kind of what you see here. That's it. Again, this is that explanation is very simple for what these guys are actually doing. There's a lot of interaction here, which maybe I'll make a video on very shortly. But again, primarily when you click the start button, there is automatically a direction selected. So that creates the initial direction where everything then determines based off of that direction. Like you move to the upper right, you continue moving to the upper right, then maybe you'll hit something, then you'll move, you'll bounce, and you'll basically get the entire breakout behavior. So as a pretty quick example, we can turn on one of these generators over here. And as you can see, we now have our ball appearing right here. And what I'm going to do is I'm going to turn on this switch, which again will allow power to flow through here, turn on the next one, turn off this one. So we're going to toggle this real quick. Do I have one of the, actually, you know what, let's drop a delay so I can get over to my little dude appropriately. So let's turn this just to a quick 10-second delay. I do need another button. I lost my drone. I do need another button to trigger this now that I'm thinking about it. So let's grab the button, trigger the switch. Let's throw our drone all the way back over. I apologize for a little bit of the hiccup, but we're going to trigger that button and we're going to watch. Again, we moved in the lower left direction until we bounced. We then bounced, causes our direction to change. We moved all the way up to here, which once again caused our direction to change. And then we moved all the way down. It did go a little bit quickly, so once again, a little bit sorry about that. But That's all based on this having a direction associated with which continued that direction to here, continued that direction to here. This direction, because we can no longer continue in the lower right, we switched it to moving to the upper right because we bounced, continued it, continued it, continued it. Here, there's a whole detection case that's really complex that we'll talk about later, but essentially we could not move in the upper right anymore, so we bounced, continued it in the lower left. And that's the general premise of how we get the bouncing movement to occur, as well as how we get the movement in general to function. So again, this is the main circuit for it. In my opinion, this is one of the easier parts to understand because it's all based on simple directions. But hopefully you guys enjoyed it. As always, if you have any questions, by all means, please ask them either here, Discord, Twitter, whatever you guys feel is comfortable. Don't forget to follow on Twitch and or Twitter, or even subscribe here. You guys are certainly capable of doing any of them. Once again, we'll remind you guys, primarily stream on Twitch, but I do try to put as much content out on here. This playlist has been really fun to kind of just discuss all of these and not really have anything that I'm trying to fit in a timeline or anything like that. I kind of like the casual atmosphere of it. But next video hopefully is going to be coming out very soon as well. Enjoy the rest of your evening. Hopefully you like the video. Don't forget to like and subscribe, and we'll see you in the next one.